Forget everything you know about modern web development and let me prove that you can build scalable, efficient web apps using,
drumroll please,
the Hate Stack, a simple alternative for people who hate the complexity of the modern web and are looking for easier yet still performant solutions. We'll jump right into coding in a second, but first, let's quickly review what this stack has to offer and how it is able to fix some of the issues we are currently facing when developing for the web. Don't get me wrong, the established front-end frameworks are powerful, stable, and more than capable of handling any use case you might think of. However, we've come a long way since the initial days of basic single-page apps. In the meantime, the web dev space became known for its complexity, and the amount of things devs have to keep track of just to build a simple application is getting out of hand. I, for one, am a fan of feeling like a junior with each release or new idea in the space, and wasting hours comparing frameworks is one of my main passions.
No question about it, I am ready to get hurt again.
However, for those of you who might be interested in actual results, a simple stack like Hate might be the smarter choice. Hate leverages some powerful tools and proven concepts. HTMX is used to enhance DOM elements and simplify the way the client communicates with the backend. Modern apps offer great user experiences, and this is usually done via client-side JavaScript. However, there is no need to overcomplicate things, and a lightweight framework like Alpine offers the perfect balance between simplicity and power. Data storage is key when building apps that should scale, and Turso is one of those new services that automatically takes care of all the scalability and maintenance issues you usually run into when serving data to your users. Finally, we'll let Go, one of the most popular and powerful languages in recent years, do all the heavy lifting on the backend in this stack. Go is known for its powerful standard library, which can handle almost any task, but I am looking for the best dev experience, so we'll use Echo as the web framework and Temple as our templating engine. We'll build our microblogging platform in 3 big phases, which should be familiar if you have prior experience in building apps. We'll start with defining our database structure, then we'll build our backend web service, which accepts incoming HTTP requests, performs the business logic, communicates with the database, and returns some HTML response back to the client. Finally, we'll focus on the front end where we'll mix together HTMX and Alpine to add interactivity to our app. Setting up the database will be really straightforward. Let's start by creating a free Turso account and downloading the CLI locally. We can then create an SQLite database using the dbcreate command. One of Turso's main selling points is its seamless replication support, and we can easily define a replica of our data in a different region of the world. This helps a lot in production when your users can retrieve data from the location closer to them and save precious time thanks to the lower latencies. Once connected to the database, let's create an article table with title and body fields and a comment table with entities linked to the article table. With this simple setup in place, we can now jump into a new Go project and build our backend service. Let's initialize a new Go module and add a couple of dependencies to the project. As I already mentioned, we'll use Echo as our web framework and Temple to seamlessly render HTML code for the client. We'll look at this in detail in a second. First, however, let's quickly review the project structure and some of Go's best practices we'll enforce while building our service. Go is well known for its fast compile times and its seamless build process. We'll define a makefile with a run command, which first generates our templates, compiles the code, and starts the resulting executable file with a port environment variable. That's it. This simplicity is a breath of fresh air, especially if your background is in a language like Java, where you have to jump through a lot of hoops when building and packaging your code. Next, let's look at the main function, which is the entry point into our program. Here, we'll define a new Echo instance, serve CSS and JavaScript files from the static directory, register handlers for various HTTP requests, which will be received from the client, and then start our app at the port we received from the make command. We could write our handlers directly in the main file, but since this project might grow in size, it's always a good idea to enforce some separation of concerns. However, we shouldn't spend too much time on premature optimizations. We'll store our handlers in the handlers package and all our business logic in the service package. Since we need to map entities to table structures, we'll define the needed structures in the model directory, and we'll use the view folder for our templates. At a minimum, our users should see a landing page when they first access the app, have access to a form to write new articles, and perform some basic operations on the articles and comments tables. Let's explore the entire workflow from receiving user data in the handler, to performing logic in the service layer, to storing data into the database, and then to rendering the HTML via Temple. Note that the following example can be extrapolated to all other workflows. The article handler is a plain structure with an article service field injected from the main function. The show article value receiver is pretty straightforward, so let's look in more detail at create article. The user will submit a form to create a new article instance, and we can retrieve the user data from the echo context. This is beyond the scope of this video, but remember that in real-world scenarios, user data should always be sanitized and validated. Then, we are sending the data to the article service, which will perform a call to insert the values in the Turso instance. Turso is a service exposing some REST endpoints, and we can use Go's standard library to perform requests to that API. In the database call function, I'm defining a command structure, which will be serialized to the format expected by the Turso API, define an authorization header, and then perform the actual post request. After some in-your-face error handling that Go is famous for, the result of our REST call is returned to the service method. Note that we'll use the database call method in all our services for the create, read, update, and delete operations. When entities are retrieved, the extract result method handles the serialization via an external library. Back in the article handler, with the entity persisted in the database, we can now send some information back to our users. As you might know, server-side rendering is a pretty hot topic, and all JS frameworks are spending a lot of time and effort to optimize this process. With Go and Echo, you get SSR out of the box, and thanks to Temple, the developer experience is close to what you're already familiar with if you have some experience with tools like JSX. Let me show you how flexible Temple is. The View directory contains a collection of components like headers, footers, or buttons, which can be reused anywhere in the UI, and layout files that define areas sharing the same functionality. I'm also defining directories for all other main views in our app. The article file showcases most of the core features Temple is offering. We'll start with a plain Go function receiving some properties, which are then rendered on the page. This content will be decorated with our base layout, and we can easily mix our code with various components. There is some other markup in here we'll come back to in a second, but first, please note that our view files don't have a Go extension. Whenever the Temple generate command is executed, our templates are compiled into Go files. This is performed almost instantly due to the power of the Go compiler, and thanks to this approach, we can enjoy Go code suggestions and validations directly in the template files. Finally, let's take a deeper look at our UI. Thanks to SSR, the client receives the expected HTML directly, but we still need ways to trigger async calls back to the server or perform small UI updates directly on the client when needed. HTMX enjoys a lot of publicity at the moment, and as you'll see in a second, this is quite deserved. The idea behind HTMX is surprisingly simple. The plain old HTML is enhanced thanks to a few attributes and directives. As a result, elements can both trigger async HTTP requests and reload parts of the UI when the response is received. So this is how we can trigger async create or delete requests with HTML markup and with 0 lines of JavaScript. While HTMX can seamlessly update the DOM based on the received HTML responses, a small library like Alpine can improve the user experience quite a bit. Alpine builds on top of the same HTML markup idea, and, despite its lightweight size and small API, it allows you to define client state, conditionally render elements, or handle events in a straightforward manner. If you've enjoyed this video, you should watch one of these ones next. Until next time, thank you for watching.